Hello again, ladies and gentlemen. We are in section 6-3, elimination with addition and subtraction. Now in this section we're going to be doing some crazy things, things you never knew that you could do before with systems of equations, but I don't think it's going to make a lot of sense for me to talk about it beforehand. It's going to do you a lot better good if you see them in action. So let's get started. So this is example 1 on page 350, solve the system by elimination. So first off, we know that we have a system, and we're solving it by elimination. These problems, they will tell you a certain method to do. Once we're in a section, it's going to tell you what method it wants you to use in order to solve the problem. When you're on a test or something like that, if you find a method that's easier or tougher, that's absolutely fine. Use whatever method you want, whichever method is the easiest to you. But in these, we're going to use elimination. Last section, we used substitution. First section, we used graphing. There's all sorts of different ways that you can solve linear systems. Here, we're going to start using elimination. So I have my system right here, my system of equations, and I need to get rid of one of the variables in order to solve for that variable, and it's going to be very similar to substitution in that, but we're going to do something crazy at this point. I'm going to take, this is something you probably never knew that you could do, I'm going to take my 4x plus 6y equals 32, and my 3x minus 6y equals 3. I am going to add the equations to each other. I'm just going to put a plus sign here, and I'm going to add them. Well, I've got 4x plus 3x is 7x. Whoa, you can do that, Mr. Weldy? Absolutely you can do that when you have a system of equations. Now here, this is the reason why I'm going to add them straight through, because I've got plus 6y minus 6y. Oh, they're so nice to us. We don't have any y left. So I stick my equal sign here, and I've got 32 plus 3 is 35. So now my equation is 7x equals 35. So I divide both sides by 7 to get x equals 5. Now that I know x equals 5, I can go back into either the first equation or the second equation. It really doesn't matter to find out what my y is. I'll use the first equation. 4x plus 6y equals 32. 4 times, and now I'm substituting, 4 times 5, since I know x equals 5, 4 times 5 plus 6y equals 32. 4 times 5 is 20, plus 6y equals 32. Subtract 20 from both sides to get 6y equals 12, and then divide both sides by 6 to get y equals 2. So my solution is 2, 5. Now, you can go back. The nice thing about algebra is you can always go back and check. So if I wanted to check, well, let's take a look at that. Now, if you were watching carefully, you saw on the last slide that I put 2, 5. This is incorrect. I put the x and the y in the wrong order. I should have put 5, 2. 5, 2. That's my x is 5, my y is 2. So once I fix that mistake, I'm going to go back and I'm going to check. So I'm going to plug in. Now, I actually found my y value by plugging into the first equation, so I'm going to plug into the second equation. 3 times my x is 5, so 3 times 5, minus 6 times my y is 2, equals 3. That gives me 15 minus 6 times 2 is 12, equals 3, and I get 3 equals 3. This checks out. I could go and plug into the first equation the exact same way, but I don't need to. I know that this checks out, and this is the correct answer. The correct answer is 5, 2. That is the only point where these two equations meet. So now we come to example 2. This is actually on page 351 in your book. I'll keep 350 up there. Page 351. And I'm going to solve this system using elimination. Now, in your book, it starts with words, and it wants you to translate the words into equations. I'm just going to give you the equations right off the bat. I'm going to trust that you can turn the words into equations. That's not the skill that we're working on right now. We're working on the actual elimination. So we have to start here. We are going to add these once again. Now, you can subtract the equations also, but I mean, this is blowing your mind right now. So we're going to add these once again. So I've got negative 3x plus 5y equals negative 11, and 3x plus 7y equals negative 1. So I'm going to add these, and I put the little plus in a circle so that I know it's not really plus, because I'm adding the equations. I'm not really adding something inside of the equation. I'm adding the system together. So I write that a little bit differently. So first I start out with negative 3x plus 3x. Well, I've got no x. They're really nice to me again. And then I've got 5y plus 7y. That is going to equal 12y equals negative 11 plus negative 1 is negative 12. So if I divide both sides by 12, I get y equals negative 1. And then I'm going to stick that y equals negative 1. Let's pick the second equation right now. It really makes no difference which one we choose. But I'll do 3x plus 7 times, well, my y is negative 1, so I've got negative 1 equals negative 1. That gives me 3x minus 7, because 7 times negative 1 is negative 7, equals negative 1. I add 7 to both sides to get 3x equals 6. And then I divide both sides by 3 to get x equals 2. So my answer now is 2, negative 1. So now let's check. Since I solved for y using the second equation, I'm going to go into the first equation on my check. Let's change colors here. Let's go to a blue for my check. So I'm going to take negative 3, this is on my check on this first equation here, negative 3 times x, my x is 2, plus 5 times y, my y is negative 1, equals negative 11. Negative 3 times 2 is negative 6, plus 5 times negative 1 is minus 5, or negative 5, plus a negative 5, equals negative 11. And so I see, obviously, negative 6 minus 5 is negative 11. Negative 11 equals negative 11, so this does check out. So 2, negative 1 is the correct answer. So now we're at example 3 on page 352. It says solve the system using elimination. On page 352, it actually lists multiple choice. I'm not listing the multiple choice here for you. Now, there's a couple things different about this one here. First of all, we do not have x and y. We have t and r. Now, the standard thing that you do when you don't have x and y, when you put your answer in a point, you show the first alphabetical, whatever the first thing alphabetical is, and then the second thing alphabetical. That's an alpha and a beta. So in this, since we have R and T, R is first and T is second, because that's alphabetical order. So our answer is going to look like R comma T. So we also, they did not line them up for us nice. So I'm going to redraw the equation so it's lined up in alphabetical order. So I've got to rearrange this first one. So I'm going to call it 5r plus 2t equals 6. So I just rearrange that, and now I also have 9r plus 2t equals 22. Now, if you notice something here, if we add these equations like we have been doing, if we add them, I'm going to end up with 14r plus 4t. That does not help me at all. I need to eliminate. That's the whole point of elimination. Boom, you got to kill one of them. So I want to kill the t's, because the t's are going to be easy to get rid of, because I've got 2 t's here and 2 t's here. So I am going to subtract this time. I'm going to subtract these equations. So I've got 5r minus 9r, which is going to be negative 4r. I've got 2t minus 2t is going to be no t. I don't have any t left. And I've got 6 minus 22, which is negative 16. Now, the only thing when you're subtracting, you've got to remember that when you subtract a negative, that's the same as adding a positive. This equation, or this problem, is nice to us. It doesn't give us that problem. That is something you do need to be aware of. Okay, so now we've got negative 4r equals negative 16. We need to divide by negative 4. Divide by negative 4, we get r equals 4. So now I need to solve for t. Really doesn't matter if we go into the first equation or the second. Let's go into the first this time. So I've got 5 times, well, r is 4, so I plug in the 4, plus 2t equals 6. 5 times 4 is 20, plus 2t equals 6. Then I subtract 20 from both sides to get 2t equals negative 14. Then I divide both sides by 2 to get t equals negative 7. So now, since I have to put them in alphabetical order for my answer, I've got 4, negative 7. So let's check that to see if it's going to work. Since we found out the value of t by plugging into the first equation, I'm only going to carry over the second equation here. So let's go over to the next page and carry that with us. So I've got my 9r plus 2t equals 22. I've got my answer 4 of negative 7. Let's check to see if that answer works. So I'm going to substitute 4 for r. 9 times 4 plus 2 times, and t is negative 7. Negative 7 equals 22. 9 times 4 is 36, plus 2 times negative 7 is negative 14, equals 22. 36 plus negative 14 is the same as 36 minus 14, which is 22, equals 22. So I am checked. That is the correct answer for my system.